So what we're going to do now is we're going to talk about how the single EX example that is the actual source code from the previous slides that we looked at last class can apply various RxJava features synchronously to reduce, multiply, and display big fractions. And this will show off basic single operations from RxJava, including fromCallable, map, doOnSuccess, and ignoreElement. So if you take a look here, you can see what the main program looks like. Let's go take a look at the main program, which is in ex1. And you can see that what this does is it uses the async tester framework, which we've talked about briefly, to register a couple of method references from this class here. And those method references will test fraction reduction synchronously. There's one variant that shows how to do that with a single pipeline of operations that runs on the calling thread. And then there's another one that shows a slightly different variant that will also run in the calling thread. So the first two tests here are not really the cool asynchronous ones. They're just here kind of as a baseline to show you how the features of RxJava work, the simple single features work. What you can see we do here is we register these method references. Then we say, hey, async tester, go ahead and run the tests. And they all go off and start running asynchronously at that point. And the main thread of control will block waiting to get the results of all those asynchronous computations. And we'll take a closer look at async tester in just a second. We'll look at a few other things first. It's really cool. So here are the methods that we're registering. This is test fraction reduction sync1, and it uses essentially a single, and it uses a pipeline of operations. So here's what it looks like. We make ourselves an unreduced fraction, which is going to be given the value of two very large constants. If we take a look here, for example, you can see these are very large constants. And we make ourselves an unreduced big fraction, because you can imagine a big fraction that large is going to take a while to reduce. So what we're then going to do is we're going to use the fromCallable method. And what fromCallable does is it goes ahead and serves as a bridge between the world of regular Java programming, kind of classic synchronous Java programming or non-functional programming, and the functional world of RxJava. And so what we do is we're going to pass in essentially a supplier lambda that will go ahead and reduce this unreduced fraction. It'll take place in the calling thread, mind you, but we'll come back to that later. And that's going to convert that result into a callable. I'm sorry, it's going to convert it into a single. So we use the callable in order to convert it into a single. And then we go ahead and we apply the map method. And you can see here the map method is going to be passed a mapper function. And that mapper function is going to convert the reduced big fraction to a proper fraction or a mixed fraction, a mixed string. So it takes an improper fraction and converts it into a mixed fraction. And then when that succeeds, when that's done, the doOnSuccess method gets called back. And the doOnSuccess method is going to go ahead and basically append a string with the result into something called a string buffer or string builder, which we're using to keep track of the results. I'll explain that why in a second. And then the last thing it does is it goes ahead and it displays the result. So when we run the program here, you can see that when we ran it, when we said test fraction reduction sync1, it returned a result that said mixed reduced fraction equal 4.5. And then up here, when we do the second one, which we'll look at in a second, it gives some different results. So what we're doing here is we're actually doing this computation. It's actually running in the foreground thread, but we're treating it as though it was running in the background. And I'll explain why we do that when we do the background example in just a little bit. The last element or the last method in this pipeline is called ignoreElement. And ignoreElement is a very interesting method. And all it basically does is it returns a completable, which will complete when all the other processing ahead of it is finished. And I'll show you in a second why we need that. We need that to make sure that the async tester framework doesn't return prematurely, but instead waits until all the processing is done. Now, for the synchronous example we're looking at here, that's kind of overkill. But for the asynchronous examples, you'll see it's very important. And so to make things as consistent as possible, we always use the same technique. This may not make a lot of sense at the moment, but when we talk about asynchronous processing, it's going to make a lot more sense. So again, just at a high level, we go ahead and reduce an unreduced fraction, get back a single that has that result. When that finishes, we map to a mixed string. When that's finished, we go ahead and have a side effect through the doOnSuccess method. And then the final thing we do is we return ignoreElement, which is a completable. And you can see that this method returns a completable. And we'll see how that gets used to better effect when we talk about asynchronous processing. Here is test fraction reduction sync 2. This uses a single and a pipeline of operations that will combine the single with various Java functional programming features like lambda expressions and method references. Once again, we start out by having a string builder, and you'll see why we need this when we do the asynchronous stuff later. We go ahead and create our big fraction just like we did before. It's unreduced. And what we're doing here is we're actually pushing this logic up into various callables or functions and so on. And so you can see what we're really doing is just printing out more diagnostic information here. We're doing the reduction. We're going to print out the results of this reduction here. We return the reduced fraction. Here we have convert to mixed string, which is a function, which again does a diagnostic and then returns the mixed string. And then the final variable we're defining here is a consumer called print result, which again prints some stuff out and then displays the results. So you can see when we run this code, it just prints out more helpful diagnostic information along the way. So we get our unreduced fraction, we get the improper fraction, and then we convert that to a mixed string. So we end up with the same result we did at the first one, but we just do some extra stuff. And we use these various variables like callables and functions and consumers and so on in order to be able to have the diagnostic information handled without perturbing the main stream we're about to show. So here's the main stream. You can see it looks pretty much identical to what we had before. We're going to do the fromCallable, passing in this callable, which is reduced fraction. We then call map on this convert to mixed string function. And then the final thing we do here is have a doOnSuccess with the print result consumer. So basically the same behavior, except that we use Java functional programming features like callable lambdas and function lambdas and consumer lambdas and so on to get the same result, but it's just done in a little bit different way. Okay, so that's an overview of those examples. And the key thing I want you to note here is that all these pieces of code are synchronous, and it doesn't really motivate the need for the powerful features like the async tester framework. But when we do the asynchronous variant shortly, we will need to motivate those features. So I will defer discussion about the async tester framework until we've gone a little further. But just be aware it's very, very cool. And it solves what would otherwise be a very thorny problem in trying to write a bunch of asynchronous code.